interstellar object whirling through our solar system is actually a nuclear-powered spacecraft sent by aliens to test how humans respond.
3I Atlas is now rushing through the inner solar system and heading toward its closest approach to Earth in mid-December 2025. And with every new observation, it is acting less like a normal comet and more like something completely unexpected.
Mostly carbon dioxide, and carbon dioxide ices can sublimate at a much lower temperature than water ice, or at the very least disintegrate to a very dense and massive cloud of gas and dust that is pushed away from the sun.
What you are about to hear makes the usual story about comets feel incomplete, because the real picture of 3I Atlas is far stranger than what you have seen so far, and the full truth is only going to unfold in this video. New approach and orbit. Right now, 3I Atlas is closing in on its nearest pass by our planet, coming to within about 270 million kilometers of Earth in December 2025, which is roughly 1.8 times the distance between Earth and the Sun. That is a safe distance in orbital mechanics, but for an interstellar object that has traveled light years through space, this is remarkably close and gives telescopes on and around Earth a rare chance to watch it in detail. You are living at the exact moment when a traveler from another star system is cutting across the neighborhood, and our instruments are locked on it. This object already passed its closest point to the Sun at the end of October 2025, sweeping through perihelion at about 1.36 astronomical units between the orbits of Earth and Mars at a speed of roughly 68 kilometers per second relative to the Sun. On its way in, it passed about 29 million kilometers from Mars, and it is on track to pass tens of millions of kilometers from Venus, and then about 54 million kilometers from Jupiter, cutting a long, shallow path through the planetary region before it escapes back into deep space. Each of those distant planetary flybys slightly tweaks its path, but none of them are enough to trap it. It remains a true visitor, just passing through. Astronomers describe its orbit as clearly hyperbolic, with an eccentricity greater than 1, meaning that 3I Atlas is not bound to the Sun and will never return once it has left. The path is retrograde and close to the plane of the planets, which makes it easier for multiple observatories to track, but also hints that it may have been nudged into this geometry long before it ever reached our system. When you look up at it in the night sky, you are seeing a one-time event. This exact comet will never sweep past Earth again. Tails, fragments, and strange structure. At first glance, 3I Atlas shows the classic comet features: a bright coma and a long tail pushed away from the Sun. But deeper imaging is revealing that its tail may be hiding something far more complex, with hints of multiple thin streamers, possible kinks, and variations in brightness that are hard to explain with a single smooth flow of dust and gas. To the naked eye, it may look like a single streak, but in the data it looks more like layered structures woven together. A recent report cited a suggestion by a Harvard scientist that the most mysterious part of the tail might be a swarm of separate objects, perhaps rocky fragments or dense clumps that are traveling along with the main nucleus. If that idea is correct, 3I Atlas could be not just a solitary comet, but the visible tip of a loosely bound cluster, the remains of an older body that broke apart before entering our system, or as it began to feel the Sun's heat. In that picture, what you see as a single visitor may actually be a small convoy of pieces sharing a common interstellar origin. There are also hints from ground-based photometry that the nucleus does not behave like a simple spinning chunk of ice. Light curves show brightness variations that suggest an irregular shape and a rotation period on the order of 16 hours, but those variations seem to be changing as the coma thickens, which could mean that jets and eruptions are reshaping the visible parts of the comet in real time. Imagine the body constantly repainting its own surface with fresh material while it spins, making its appearance evolve week by week as it moves past the Sun. Spacecraft encounters and real-time measurements. While telescopes on Earth watch from afar, spacecraft across the solar system are turning their instruments toward 3I Atlas, and in some cases, actually flying through regions of space that it influences. A recent analysis predicted that the ion tail of 3I Atlas, the long stream of charged particles stripped by the Sun's radiation, may be crossed by spacecraft such as the Europa Clipper spacecraft and the Hera mission spacecraft around late 2025, letting those missions sample the charged environment indirectly. They do not fly near the nucleus, but they can pass through the invisible footprint that this interstellar object leaves in the solar wind. A NASA report stated that the Psyche mission spacecraft, currently on its journey to a metal-rich asteroid, has been repurposed during cruise as a remote observer to track 3I Atlas with its instruments and to watch for subtle changes in brightness and activity. These spacecraft measurements cannot produce the dramatic photos you might expect, but they can detect tiny changes in plasma, dust, and magnetic fields as both the spacecraft and the comet share the same heliospheric environment. That kind of data tells you how this visitor interacts not just with light, but with the entire energetic bubble of particles around the Sun. Combined with the ongoing campaigns at large observatories on Earth, including optical telescopes, radio arrays, and wide-field survey instruments, this effort makes 3I Atlas one of the most heavily monitored comets in history. Astronomers are collecting continuous time series data across many months, building a frame-by-frame record of how an interstellar object wakes up, flares, and calms down as it flies past a star for what might be the first time since it formed. You are watching the first high-definition time-lapse of a piece of another system moving through ours. Weird surface and ice volcanoes. The biggest surprise in the latest reports is that 3I Atlas appears to be erupting with what scientists call ice volcanoes, or cryovolcanoes, blasting material from beneath its surface into space. High-resolution images and infrared data show localized jets and plumes that look more like focused eruptions than the smoother, global outgassing seen in many ordinary comets, suggesting buried pockets of volatile ices that are venting through cracks. Instead of behaving like a quiet, dirty snowball, it acts more like a restless world that is trying to release pressure from its interior. A recent study indicated that the dust and gas from these eruptions are unusually rich in complex carbon-bearing material, making 3I Atlas look like a very primitive carbonaceous object that has preserved chemistry from its original home system. Measurements of the polarization of light scattered by the dust in its coma match patterns seen in some distant trans-Neptunian objects in our own system, hinting that its surface may be a dark mixture of fine grains, porous clumps, and embedded ice rather than a smooth, reflective shell. That means every eruption you hear about might be exposing material that has not seen starlight since the object was born around another star. Infrared and ultraviolet observations by major space telescopes have already started to dissect the gas around 3I Atlas, hunting for water vapor, carbon monoxide, carbon dioxide, and sulfur-bearing molecules. Early reports suggest that the balance between these gases is not exactly like most known comets from our own Oort cloud, which raises the possibility that this object formed in a colder or chemically different region around another star. If that is true, then 3I Atlas might be the first physical sample of another planetary nursery that humanity can study in detail without leaving the solar system. Theories, mysteries, and what comes next? All of these new observations feed into a growing set of theories about where 3I Atlas comes from and what it is made of. Some researchers argue that its primitive carbon-rich chemistry and cryovolcanic activity make it a frozen building block from the outer regions of another planetary system, perhaps ejected by the gravity of giant planets soon after its birth. Others point out that its similarities to some of our own distant icy bodies suggest that many planetary systems build very similar small objects, and that 3I Atlas is a sample of something quite common in the galaxy that we are finally seeing up close. There is also an open debate about how long 3I Atlas has been wandering between stars before arriving here. Modeling of its path through the Milky Way suggests that it could have spent hundreds of millions or even billions of years in deep space, cooled to just a few degrees above absolute zero, with its surface slowly altered by cosmic rays and tiny impacts before one close stellar encounter finally sent it toward our region. Every particle that leaves its surface now carries a record of that long journey. The most intriguing part is that the story is still unfolding as the comet continues to move away from the Sun and past Earth. Observers expect the brightness to gradually fade as it recedes through the constellations Virgo and Leo during December 2025, but the next rounds of spectra and images, especially from powerful space telescopes watching it after perihelion, may reveal even more unusual molecules, more complex tail structures, and clearer, sharper signs of those suspected ice volcanoes pulsing on its surface. Let us know what you think in the comments below, and do not forget to subscribe so you do not miss any new videos. Thanks for watching.